Hello friends, in last lecture we are discussing about the non-conventional machining processes. Those are based on mechanical energy and electrical energy. Now in this lecture we will discuss on the remaining two types of the non-conventional energy processes, which are based on, it may be from chemical energy, it may be from thermal energy, right? We have to discuss all these processes in detail. Now we go for next process, that is a photochemical machining. In photochemical machining process, or it may be called as a photochemical milling, or also it will be called as a photo etching. It is a chemical milling process which is used to fabricate sheet metal component using a photoresist and etchant to corrosively machine away the selected area. The image of the part to be manufactured is photographically transferred on the metal part, and the unwanted metal is removed by using a chemical etchant. Means, if you are considering this flow chart, right, photochemical machining process flow chart, we are producing the diagram by using AutoCAD, and we are carried out the photo processing by using the photo tool, and at the same time we are selecting the material or metal, and we have to prepare the metal. We have applied photoresistance coating on that metal, and both are to be combinedly carried out the photoresistance resistant processing. After that, etching is to be carried out, and after etching, stripping, and at the last inspection and packing is to be carried out, and finally that part is dispatched. Now how this process is to be carried out in stepwise, we have to discuss in next slide. That is a here. This is the process step for the photochemical machining process. You have to generate the shape of a selected object, prepare the plastic artwork by using the scale, then photographically you have to produce the reduced actual size, then we have to apply the photopolymer, then we have to apply the transparency on a wax sheet to expose the ultraviolet rays or X-rays, then you have to develop the exposed photopolymer, and finally you have to etch the part from the metal sheet, and at last you have to remove the polymer so that you are getting the finished parts. It will be carried out in a photochemical machining process. Now next process, it is related with thermal energy. In thermal energy based processes, we have to use the application of heat in order to remove the material from the workpiece. The first process that will come under the thermal energy based non-conventional process, that is the laser beam machining process. If you are observing this diagram of this laser beam machining process, here we are getting the one power source, this power supply, then there will be one enclosure, it is having this flash lamp, and power is supplied across this flash lamp, and this flash lamp is wrapped around this laser crystal which will produce the laser light, right? And this laser crystal, it is having two ends. That is the first one, that is a reflective end, and this one is the partially reflective. And at the end of this container we are providing the one lens, concave lens, that will concentrate all these laser rays at a single point, and that laser, it will be impinging on that workpiece. Now how it will be happen? That is when we are applying the voltage across this flash lamp, it will generate the light, and that light, it will be create the laser rays, and it will be transferred from reflective end and partial end, and this laser light, it will be generated by this laser crystal, when they are passing through this layer, they are get concentrated and they are impinging or striking on upper surface of the workpiece. And when this concentrated ray strikes on upper surface of a workpiece, heat is to be generated. Kinetic energy, it will be converted into heat energy, and that heat is utilized to melt or vaporize that part of the workpiece because of a heat. Here, in laser beam machining process, it will work on a principle that when high energy laser beam strikes the surface of the workpiece, the heat energy contained by the laser beam gets transferred to the surface of the workpiece. This heat energy absorbed by the surface of the workpiece, and that heat will melt and vaporize the material from the workpiece. In this way, this laser beam machining process is to be carried out. You getting this? Now, another part or another process which is based on a thermal energy based process is plasma arc machining process. It is also having the same principle as like laser beam machining, but here we are utilizing plasma arc instead of a laser. See here the working diagram. Here we are applying DC power supply whose positive terminal is connected to the workpiece, so this workpiece is act as an anode, and negative terminal is connected to the tungsten electrode. That is a non-consumable one. It will be act as a cathode, right? And it is a non-consumable tungsten electrode, right? When we are passing the plasma rays through this electrode and applying the voltage and maintaining the gap, because of the ionization of a plasma gas, this plasma arc is to be produced, and the temperature of that plasma arc is ranging in between 10,000 to 30,000 degrees centigrade because of a ionization takes place, and that much temperature is sufficient to melt out a particular part or to remove the material from the workpiece. See here, in plasma arc machining, the metal is to be removed by the process in which metal is removed by focusing high velocity jet of high temperature. It is ranging in 11,000 degrees centigrade to 30,000 degrees centigrade ionized gas on the workpiece. So, in plasma arc machining, again the material from the workpiece is to be removed because of the heat energy, and that heat energy will cause melting and vaporization of the material from the workpiece. The next step is related to the electron. Means the next process, it is called as the electron beam machining process, or in short it will be called as the EBM process. In EBM process, again same principle we are using. In a previous one, that is a laser beam machining process, we are utilizing the energy of a laser in order to remove the material from the workpiece. In plasma arc machining, we are using the heat energy of the plasma arc to remove the material from the workpiece. Likewise, in electron beam machining process, the material is removed from the workpiece by using the beam of electrons. Here, in the diagram, what we have observed that there will be high voltage cable, cathode grid, this will be the anode, this will be the optical view system to observe this electron stream, magnetic lens, deflection coils, so that whatever the electrons is to be generated, that will be passing through this wall, they are converging through this deflection coil, and concentrated electron beam, it will be impinging on the surface of the workpiece. But in this process, one parameter you have to must consider: the total setup or workpiece, it must be placed in a vacuum chamber, where in this electron beam machining process, the machining operation on the workpiece is to be carried out in a vacuum chamber. Here, in electron beam machining process, electron strikes the workpiece with a high velocity, as the electron strikes the workpiece, the kinetic energy of that electron, it will be changing into heat energy, and this heat energy produced is used to melt and vaporize the material from the workpiece. And the workpiece, it must be placed in a vacuum chamber. That is very important in case of a electron beam machining process. Likewise, there will be next method we may have, that is ion beam machining. Means we have to use the ions of the gases in order to remove the metal. We will see in a detail in last chapter. Then last part of this chapter, it is related with the comparison of some of the main non-conventional machining processes. The first comparison, it is between electric discharge machining and electric chemical machining. The first part in electric discharge machining, that is in electric discharge machining, we are using dielectric fluid as a conducting medium between tool and workpiece, and where in electrochemical machining, we are using electrolyte, that is the NaCl, as a conducting medium between tool and workpiece. The second part, it is related with the tool life. In electric discharge machining, the wear of the tool takes place during the process, but in electrochemical machining, no wear of a tool, it will be takes place during the process, so the life of the tool, it will be high. The next part, it is related with the generation of the heat. In electro discharge machining, heat is generated during the process, but in electrochemical machining, no heat is to be generated during the process. The next part, it is related with the material removal rate. In EDM, the low MRR is there, and in ECM, the material removal rate is high as compared to the EDM. The next part, it is related with the working principle of these processes. The EDM, it will be works on spark erosion, whereas the ECM, that is electrochemical machining, it will work on Faraday's law of electrolysis. The next point, it is related with the metal removal process. Means in case of EDM, metal is removed by melting and evaporation, and in a ECM, the metal is removed by the electrochemical reaction. The last point, it is related with the tool. The tool used in a EDM, it is oversized for machining inside and outside surface, and in case of ECM, the tool used are having the required size of the workpiece. Are you getting the difference between the EDM and ECM based on a conducting medium, tool wear, generation of heat, metal removal rate, principle of working, method of metal removal, and the type of the tool or size of the tool we are using. All these parameters we have considered for comparing this electron discharge machining with the electrochemical machining process. The next comparison, it is related with the EBM and LBM. EBM is the electron beam machining, and LBM, that is the laser beam machining. Both these processes are based on thermal energy. The first parameter, it will be related with how material is to be removed or how energy is to be converted. In electron beam machining, when high velocity electron strikes the workpiece, its kinetic energy is converted into heat energy. Whereas in laser beam machining, when excited atoms release the photons in the form of laser rays, laser beams, that will be generated and which will strike on a workpiece, and it will melt the workpiece. Means in a electron beam machining process, the material is to be removed because of the action of the electrons, and where in laser beam machining, the material is to be removed because of the action of a laser. In electron beam machining, electron gun is needed to supply the electrons on a workpiece. But in case of a laser beam machining, laser material is used as a tool. In electron beam machining, accuracy is good. It is comparatively more as compared to the EBM. Metal removal rate, it will be low. It will be high in laser beam machining. The complete process, it must be kept in vacuum. You must have to remember this point. Whatever the electron beam machining process, the total process must have to kept in a vacuum. Whereas vacuum is required between flash lamp and ruby rod in case of a laser beam machining. The electron beam machining, it is usually used for the metals, but the laser beam machining we can use for any kind of the material. It is suitable for any type of the material, but not suitable for plastic. You have to consider all these points while comparing electron beam machining with the laser beam machining. Ready? The next comparison, it is related with the dielectric fluid and electrolyte. That is, both are the conducting medium. We can compare dielectric medium. It is used as a conducting medium in EDM, and electrolyte, it will be used as a conducting medium in ECM. This dielectric medium, it will be act as a conductor and insulator both, whereas the electrolyte medium, it always provides passage for supply of electricity. The tool where it takes place in a dielectric field, whereas the electrolyte selected in such a way that there is no wear of the tool. Means in order to avoid the wear of the tool, you have a choice to select the electrolyte medium. It may or may not be corrosive in nature, but electrolyte, it should be a non-corrosive in a nature. Means in previous slide in EDM we are using dielectric as a conducting medium in EDM, whereas electrolyte solution, it will be used as a conducting medium in ECM. What is EDM? Electric discharge machining. And what is the ECM? Electrochemical machining. Are you getting these points? Now we go for a last comparison related to our this chapter. That is a comparison between electron beam machining and electrochemical machining. Right? The first point, it is related with which kind of energy we are used for carrying out that machining process. In electrobeam machining process, the thermal energy we have to use, and this ECM process, it is based on electrochemical energy. Right? The second point of comparison, it is related with the way of material removal. There is in EBM, the material is removed from the workpiece in a molten and vaporized state, whereas in ECM, the material is removed from the workpiece is in ionic form. The third point of comparison, that is a high intensity beam of electrons which is focused and directed on a workpiece is used to supply heat for the material removal. Means the electron beam, it will be utilized to remove the material from the workpiece, whereas in electrochemical machining, the electrochemical dissolution between workpiece, electrode and electrolyte, it will lead the process of the material removal by following the laws of Faraday. Right? The fourth point of comparison between EBM and ECM, that the tool which is not used in EBM process, the electron beam itself removes the material from the workpiece. Means the tool is absent in EBM, whereas a form tool having certain profile shape, it is used as a tool in case of a electrochemical machining process. The fifth point of comparison, that is The workpiece is not immersed in any fluid. The entire machining operation it will be carried out in a vacuum chamber in case of a electron beam machining process. Whereas in a electrochemical machining process, the workpiece and tool both are must be immersed in a suitable electrolyte in order to carry out the electrochemical dissolution to remove the material from the workpiece. The X-ray may be generated during the EBM process. There will be no any case of production of X-ray in case of EC. The last point of comparison in a electrobeam machining process offers higher material removal rate, whereas the material removal rate in a electrochemical machining it is a very low as compared to the electron beam machining. Now, in this way, in a 4-part, we have studied the first chapter, that is the overview of a non-conventional machining. From the beginning, in first lecture, we have seen the need of the non-conventional machining, classification, its comparison. In second lecture, we focus on the non-conventional machining process, which is based on mechanical energy. In third lecture, we focus on the non-conventional machining processes which are based on electric energy, and in fourth lecture we are focused on the non-conventional machining processes which are based on chemical energy as well as thermal energy, and at last we are comparing certain non-conventional machining processes we have studied in this chapter, that is the overview of a non-conventional